Atoms are the building blocks of matter, and in order to develop a good understanding of the elementary forces and laws in electrical engineering, you need to be familiar with the concepts of protons, electrons and charges. And in this tutorial I will therefore show you how you can calculate the number of atoms and thus the number of electrons in objects such as this coin here. My name is Andreas from The Fearless Engineer. Let's go! If you want to know more about the background, just watch the theory video on atoms and charges. The link can be found in the cards above and also in the playlist on my channel as well as on my website on thefearlessengineer.com. And this tutorial is more about getting some practice and about answering the question of how many electrons actually are within a copper coin. I will show you which parameters and formulas you need and how you can get to the results very easily. We also take a look at the periodic table of elements, we clarify the terms mole and Avogadro's number, and also we calculate the number of atoms in a given quantity of matter in a few very simple steps. And here we go. In order to get the number of electrons in our coin, we have to perform the following sequence of steps. The first is we get the atomic weight of copper as well as the number of protons in the nucleus from the periodic table of elements. And then secondly, we explain the terms mole as well as Avogadro's number. And thirdly, we use those to calculate the number of atoms per gram of copper and also for the entire weight of the coin. And then fourth, we calculate how many electrons we have in the coin. And off we go with step number one. Now in the first step we want to get the atomic weight of copper out of the periodic table of elements. And if you don't have one at home, just look it up on Wikipedia. That's what we will do just now. And first we have to locate the element copper, that's the one with the abbreviation Cu, in the table of elements. And in the description you can see that the atomic weight is just in the upper right corner. In the case of copper, this is 63.546 grams per mole. And in the second step, we want to look at how we have to interpret this number and we have to learn about what a mole actually is. And the mole is not a weight unit, which is often believed, but a quantity unit. 1 mole contains about 602 trillion particles of a substance. That's 6.02 times 10 to the power of 23. Now this number might sound a little bit chosen at random, but it actually was determined with the element hydrogen. Now what you can see here is the atomic weight of hydrogen, which is about 1, which is 1 gram per mole. And since 1 gram of hydrogen contains about 6.02 times 10 to the power of 23 atoms, this number can be used to convert between substances and is usually called Avogadro constant. But now let's get back to our element of interest, which in our case is copper. Now the atomic weight of copper, which is 63.546 gram per mole, thus means that 6.022 times 10 to the power of 23 copper atoms actually weigh 63.546 grams in total, which is 63 times more than the same amount of hydrogen atoms. Now in the third step we can calculate the number of atoms in our coin that we assume to have a weight of 1 gram. And this can be done with a simple rule of 3. To do this we divide the Avogadro constant by the atomic weight, which gives the number of atoms in a gram of copper, and then we simply multiply the result by 2.5 grams, which is the weight of the coin, and we get as a result 2.369 times 10 to the power of 23 copper atoms, which make up our coin. Now to find out the number of electrons, we again have to look into the periodic table of elements, and the number 29 in the upper left corner indicates how many protons are contained within the atomic nucleus of copper. And if we know the number of protons, then we also know the number of electrons orbiting the nucleus, which is exactly the same number, in this case 29. And therefore, in the fourth and last step, we only have to multiply the number of copper atoms by the number 29, and as a result we get the number of 6.87 times 10 to the power of 23 electrons contained in our copper coin. Now a quick word about the 5-cent coin we have used as an example so far. It's not actually made out of 100% copper, but it's only coated with it. The core is actually made of iron. But if you wanted to, let's say, calculate the number of atoms in a piece of copper or aluminum wire for that matter, you now have a proper procedure to actually do this. And the only things you will need are a good scale and a copy of the periodic table of elements. Oh, and by the way, the number of electrons in an aluminum coin of the same weight is about 6% higher than for copper, which contains more than twice as many aluminum atoms. And if you want to know how to arrive at this result, then you now know what to do. In the next video we will take a close look at the electrostatic force between charge carriers, and we will also introduce the concepts of electron gas and of drift velocity. And in the next tutorial we will use our copper coin from this video as well as a piece of scrap metal from my workshop and some lemon juice from my kitchen to build our own battery and generate current and voltage from scratch by ourselves. Oh, and if you have any ideas for further experiments with unusual materials, or if you feel like a certain topic should be covered in this tutorial series, please feel free to write that into the comment section down below this video. So, see you soon here at The Fearless Engineer.